Hello, my name is Skylar Petro, and the two concepts that I've chosen to discuss are boundary shear stress and channel reach morphology. I will be using the bridge or creek under the Red Bridge at the Drinking Horse Trail to explain these concepts. The first topic I'll be discussing is boundary shear stress, which can be thought of as the shear stress experienced by the beds and the sides of a channel where water is present. Stress can be thought of as the force applied downward on the bed by water. The shear aspect is the downstream angular component that causes deformation in the bed. The equation for boundary shear stress is rho W dgs. Rho W is the density of water, d is the depth of water, g is the gravitational constant, and s is slope. Since rho W and g are unchanging, stress is reliant on the slope and depth of water. In this stream, both slope and depth are relatively low, in comparison to a channel that has either a steeper slope or a deeper water level. This channel would have a lower boundary shear stress. By increasing either the slope or the depth, the boundary shear stress would be increased. The next topic is channel reach morphology. A channel reach is a stretch of river that has similar traits of either material or components of the bed. There are different types of reaches that are determined by how the channel was formed. In alluvial reaches, the morphology is formed by flowing water and sediment transport. However, there are varying types of alluvial reaches which are defined by their transport, sediment type, slope, and roughness. This reach resembles what is called a plain bed reach, which is an alluvial type reach. These systems are easily identified by the cobbles and gravel in small grain sizes, which can be observed here in this bed. The bed systems do not have any major features and are found further downstream in this system, which is where we are sitting here in the Bridger Creek. This type of system has relatively shallow slope, and these bed reaches are the transition point between the steeper channels further upstream and shallower channels downstream. The steeper channels upstream have supply limits, and the lower channels that are downstream face issues with transport limitations. Channels at this point along the creek will be less rough than higher up in the channel, and this section of river will be also considerably straighter than the other portions of the channel. Thank you.